Good day, everyone. This is teacher Justina, and welcome back to my channel. If you are still new, then do not forget to subscribe, like, and share, and also leave your comments below. And hit the notification bell for more video updates. And then also, I would like to remind you that please do watch my video starting from the very beginning all throughout the end because I'll be giving examples from an easier to difficult. And our video for today is all about factoring sum in difference of two cubes. Okay, so let us explore. But before anything else, let us do recall how to identify perfect cubes. So when can we say a constant is a perfect cube? Okay, so if we can get its cube root. When we say cube root, uh, we will be multiplying the said root three times to itself, and thus if we can get uh, the exact given by multiplying the roots three times, then therefore the root is correct. So is 27 a perfect cube? Okay, so it's a yes, and its cube root is 3. And 64 is also a perfect cube, and its cube root is 4. Because if we will be multiplying 4 times 4 times 4, of course 4 times 4 is 16, times 4 is 64. So therefore 64 is a perfect cube. What about 12? I think there's no such number uh, that if you will multiply it by itself 3 times, there's no such a product of 12. So therefore 12 is not a perfect cube. What about negative 125? Okay, so is there such a number? If you will try a negative 5, multiply by negative 5 and another negative 5. Negative 5 times negative 5, it will gives us positive 25. While multiply negative 5 to 25, it will gives us negative 125. So therefore, negative 125 is a perfect cube because its cube root is negative 5. Okay, aside from knowing if a constant is a perfect cube or not, what will happen if we are to identify an algebraic expression, this time it is together with a constant and a variable. And then how do we know if they are a perfect cube? So let us try C number 5. Now, if a literal factor or a variable will be raised to an exponent, when can we say if it is a perfect cube? All you need to do is you try see the exponent of the variable. So we are talking about perfect cube. Okay, so if we are to recall perfect square, we can only say if an expression is a perfect square if the exponent is exactly divisible by 2. So like p to the 4, this is a perfect square because the 4 as an exponent can be exactly divisible by 2 or can be divided by 2. So 4 divided by 2 will gives us p to the 2. And p to the 2 is the square root of p to the 4. So now at this time we'll be getting or we will be identifying if a certain algebraic expression is a perfect cube. So it's no longer that we need to divide the exponent by a 2, but this time it's already a 3. So far, y cube, the 3 there is exactly divisible by 3. So therefore, 3 divided by 3, thus it will be a 1. So therefore, y cube is a perfect cube because its cube root rather is y to the power of 1. This is understood that there is a 1 there because there is an imaginary one because 3 divided by 3, thus we're able to get the cube root. Now what about the h to the 9 and y cube? Remember that 8 has a 9, the y has a 3. So therefore, for the 8 alone, if we have to divide 9 by 3, then it will give us 8 to the power of 3. While the y to the power of 3, 3 divided by 3 as our common divisor as to find out if it is a perfect cube, exactly divisible by 3, thus it will give us a y to the power of 1. So therefore, is this a perfect cube? Yes, h cube y to the power of 1 is the cube root. What about number 7? M to the 12 and k to the 10. Remember, we have two variables, the m and the k. And then so far, the 12 is exactly divisible by 3. And it will possibly gives us m to the power of 4 because 12 divided by 3 is 4. But what about the 10? Is 10 exactly divisible by 3? It's not. So therefore, if we are going to divide 10 divided by 3, there will be a remainder. So it's not that we're able to get the cube root of the first variable, but in the second we're not. Thus, the entire expression has no uh, cube root, or it's not a perfect cube. Okay, so what about number 8? So far, the negative 8 um, is a perfect cube. Why? Because the negative 8 has a cube root of negative 2. Because if negative 2 will be multiplied 3 times, why 3 times? Because we are talking about a cube of a number. So negative 2 times negative 2 will give us positive 4. And there is a negative 2 still there, so it will give us negative 8. So the negative 2 is our cube root. We have the same root. So negative 2 as our constant. What about the d to the 6? So 6 is exactly divisible by 3. Then it will give us negative 2 for the negative 8. D to the 6, 3 will divide 6, that will gives us a 2, and then 24 divided by 3, we have an 8. So therefore, the cube root of negative 8 d to the 6, c to the 24 is negative 2d c to the 8. So therefore, number 8 is a perfect cube. Okay, number 9. Let us have it base by base. Remember, 27 is a base, R, a P, and another R in here. So therefore, if we are trying to get 27, its cube root is 3. Okay? While this one, this 3 is the cube root of 27. R to the 21, 21 divided by 3, we have a 7. And 9 divided by 3, we have 3, so we have a p cube. And then the r to the 12, we have r to the 4. But remember, the r to the 7 and the r to the 4 are still can be simplified using the law of exponent, the first law of exponents. So therefore, this will become 3r to the power of 11 because 7 plus 4 is 11, and then p to the power of 3. So therefore, this is the final answer in number 9. So what about number 10? Is negative 64 still a perfect cube, t cube and y cube? So negative 64, what will be that number that if we will be multiplying it by itself 3 times will gives us negative 64. And of course, it will be negative 4. And that negative 4 is the cube root of 64, while the t cube, y cube, we have t to the 1 and y to the 1. Okay, so far, I hope you have already recalled as to how to identify perfect cube. It's either a constant or an algebraic expression. Okay, so since you are already familiar with expressions which are a perfect cube, then let's proceed to factoring polynomials, which is a sum of two cubes. So you are given x cubed plus 8 And so for this expression is said to be sum of two cubes. Why? Because when we say sum, so the presence of the plus sign is between these two expressions. And what are these two expressions? They are uh, two cubes. They are two perfect cubes. Okay, so we are going to prepare first in getting their factors. We are to prepare two sets of parentheses because we will be having a binomial set of factors and a trinomial set of factors, meaning two terms times three terms. Okay, so let us now have the different steps in factoring sum of two cubes. We are going to the first thing there is we need to get the cube root of the first in the second term of the given. So the first term in the given is x cubed and its cube root is x because it says get the cube root of the first term and then of the second term. So the cube root of 8 is 2 because if x will be multiplied 3 times by itself, we'll be getting x cubed. And then at the same time, y2 is the cube root of 8 because 2 multiplied 3 times by itself, 2 times 2 times 2 will gives us 8. So therefore, 2 is the cube root of 8. And what should be the sign between x and 2? So the sign between x and 2 is uh, that will be our second term. We need to follow the middle sign of the given. So our given is x cubed plus 8. So that plus will be followed as the sign between the cube root of the first and cube root of the last term. Let's proceed to the trinomial set. So what will be our first term in the trinomial set? Okay, it says that we need to get the square of the first term in the binomial set. So what is the square of the first term in the binomial set? So therefore, our binomial set first term is x. So what is its square? So it's x squared. Okay, and then followed by the second term. Multiply the first and the second term of the binomial. So the first term of the binomial is x and then the second term is 2. Then its product because it says multiply, so 2x. And then what should be the sign? The sign will be opposite of the binomial set. So it's the additive inverse. So if this is a plus, then it's a minus. Then the third term in the trinomial set is taken from this plus square the last term of the binomial. So what is the square of the binomial set of the second term? So it's a 2, it's a plus 2. So squaring positive 2 will gives us a positive 4. So therefore our factors of x cubed plus 8 are x plus 2 times x squared minus 2x plus 4. And how do we know if our factors are correct? So far we need to multiply the factors x plus 2 times x squared minus 2x plus 4 applying the distributive property. So x times x squared, we have x cubed. Well, x times negative 2x will gives us negative 2x squared. And then x times positive 4 will gives us positive 4x. We are done distributing the x. Let's proceed to multiply or distribute 2 to the three terms. So 2 times x squared, we have positive 2x squared. And then we write the 2x squared in line with the negative 2x squared because they are similar terms. And then the 2 and the negative 2x will be multiplied, so it will gives us negative 4x, while 2 times positive 4 will gives us positive 8. So after which, we are done distributing the first term in the binomial to the three terms in the second term of the binomial to the three terms, and that is distributive property. Let's proceed to vertical addition. So x cubed will be brought down. The negative 2x squared and the positive 2x squared will be combined because they were similar terms and they have the different signs. Thus, we need to subtract them and thus it gives us a 0. While this one will gives us a 0 also. Then we need to bring down a plus 8. So as you have seen, x cubed plus 8 are the remaining terms. And so far, This is our given, which is x cubed plus 8. Okay, so to explore more, let us have the second example. So the given there is 27k to the 6 plus 1, but we need to investigate them before factoring them. So far, the 27 as a constant is a perfect cube because what is that number if we will be multiplying by itself 3 times will gives us 27 and it says 3. So 27 is a perfect cube, then k to the 6 is our exponent of a variable. Our variable k is this divisible by exactly divisible by 3. Yes, so 6 divided by 3, it could be divided and it will gives us an answer of 2. Well, a 1 is 1 a perfect cube. Yes, a 1 is a perfect cube. So therefore we are now ready getting their factors. So let us now proceed. We are going to prepare two sets of parentheses, and then for the binomial set we need to remember the step. We need to get the cube root rather. We need to get the cube root of our first term in the given. So 27, it gives us a 3, while the k to the 6 divided by 3, we have uh, k squared already. And the cube root of 1 is positive 1. Okay, so we are done with the binomial set. So what shall we do now? We will be getting the trinomial set. And what is the trinomial set? So let us now proceed to the first term of the trinomial set. The trinomial set first term says that we need to square this first term of the binomial set. So that means we have to have 3k squared, square it. So therefore, 3 square will gives us a 9, while k squared to the power of 2, remember that we need to multiply the inner to the outer exponent. So therefore, that will be 9k to the 4. So that's it. 9k to the 4 is the square of our first term. And then remember that the second term of our trinomial set is always the additive inverse. So when we say additive, it's the opposite. So we have to have a minus. So therefore, that is minus. And then where did we get the 3k squared? Because the second term of the trinomial set says that we need to multiply the first and the second term of our binomial set. So 3k squared times 1 will gives us 3k squared. And for our last term, what is the square of our second term of our binomial? It's positive 1. So therefore, this is our uh, 3k squared plus 1 times 9k to the 4 minus 3k squared plus 1. If multiplied together, we will be getting our given 27k to the 6 plus 1. Okay, let's proceed to the second, uh, next example. We have d to the power of 12 and then c to the power of 9 plus 125 8 to the 24 x to the 6. So investigating them if they are a perfect cube. Okay, so they are both variables. So 12 exactly divisible, yes. 9 divisible by 3, yes. What about 125? Is there any number that can be multiplied by itself 3 times will gives us 125? Yes, there is, and it's a 5. Is 24 a perfect cube? Yes, divisible by 3. Okay, so it is. Well, the 6 also is divisible by 3. So, let's now proceed. We have the parentheses for the binomial in the trinomial set. So, what is the binomial set first term? We need to get the cube root of the first. So, the cube root, so when we say cube root of the first, so we just simply 12 divided by 3 and then c to the power of 9. So therefore, this will be 12 divided by 3. This will becomes 4. And c to the 9 will be divided by 3. It will gives us a 3. So far, that is our first term in our binomial set. And then for our second term of our binomial set, what is the cube root of 125? It's a 5 because 5 times 5 times 5 will gives us 125. So it's already 125. So we have a 5 as the cube root. 8 to the 24. So the 24 will be divided by 3 will gives us 8. And then the x to the power of 6, the 6 divided by 3 will gives us 2. So therefore, is this our second term of our binomial? Sige, let us reveal. Okay, so therefore, it is plus 5 h8 x to the power of 2. And then for our trinomial, we simply multiply. So this is a variable with an exponent. So therefore, how to get the first term of our trinomial is simply we just copy the d there, and then um all these exponents will be multiplied by 2. So therefore, this will become, because we are squaring, so that means d to the 8 and c to the power of 6 already. What do you mean by squaring this? So squaring d to the 4 and c to the power of 3, squaring them. So it's just correct. They are just the same. So therefore, the square of our first term in the binomial set is our first term in our trinomial. So d to the 8 and c to the 6. And next, we simply multiply them all. So 5 times, so there is a 1 here. So 5 times 1, and then attach all the variables with their exponents. Okay, but why this is minus? Because it's always the additive inverse. Or else, if you will be mistaken in writing the additive inverse, then you are getting the wrong factors. So therefore, where did we get this? By multiplying them. Thus, we have the second term of our trinomial. And for our last term in the trinomial is simply the square of our second term of our binomial. So we have 5h to the 8 x squared, then square of it. So simply square the 5, it's 25. Remember that we just simply apply the law of exponents. Inner exponent times the outer. This will become 16, and then x to the 4. So therefore, is this our trinomial set third term? Okay, so 25 h to the 16, x to the 4. Okay, so far we are done with getting the factor of a polynomial, which is a sum of two cubes, but this time it's no longer sum of two cubes, but difference of two cubes. So where are the expressions that refer to the difference of two cubes? So here are number 5 and 6. Difference of two cubes. So difference, there is the presence of the minus, and the two cubes are the first and then the second. And so far, they are a perfect cube because 8 is a perfect cube, while y cube and h cube too. So let us now have their factors. So what is the first step? Getting the cube root of our first term in the given. So what is the cube root of 8? The cube root of 8 is 2. And then the cube root of y cube, the 3 divided by itself will be 1. So therefore, 2y is the cube root of our first term. And then what is the cube root of 8's cube? So the cube root of 8's cube is h. And then where did we get the minus? Because it is always said that the binomial set sign should always follow to the sign of the given. Sige, let's proceed to the trinomial set. The first term in the trinomial set is the square of our first term in the binomial set. So therefore, 2y to the power of 2 will gives us 2 square y squared. So therefore, this will be 4y squared. And that's it. And then, what is the product? So the product of the first and the second, so that will be 2hy. And remember that in the sum of two cubes, we have here a plus in here and the additive inverse in the trinomial set. But this time, since it's difference, so the binomial set has a minus, and the trinomial set, the additive inverse of our minus will be already a plus. So remember, they are always opposite. Okay, they are always opposite. Okay, and then the third term, what is the square of h? It will be h squared. Remember that even if it is a sum or difference of two cubes, remember that our last term in the trinomial set is always positive. Okay, sige, let's proceed to number 6. This time, uh, this is involving a fraction, but still we are to apply the same concept. So we are going to have step 1, we need to get the cube root of our first term. Remember, 1 is a perfect cube, and then its cube root is 1. And 8 is a perfect cube in which the cube root is 2. So therefore, 1 half. And then 6 divided by 3, it will gives us n to the power of 2. And that is why we have 1 half n squared. And then, whatever the sign in here will be followed. What is the cube root of 64? It's 4. And then 18 divided by 3 will have 6. So therefore, is our second term in the binomial set is negative 40 to the 6. It's a yes. Then let's proceed to the trinomial set. We need to square the first term of our binomial. So we have 1 half n squared, then square it. This will become 1 half times 1 half will be 1/4, and then n to the power of 4. Okay, so that will be our first term in the trinomial, and our second term will be this one, will be multiplied together. So 1 half n squared times 40 to the 6. So remember, what is 1 half of 4? So it's a 2. So you just simply attach the variable n squared t to the 6. Okay, and that's it. 2n squared then t to the 6. Again, they are always opposite. Okay, and then the last term in the trinomial is simply the square of negative 4t to the 6. So what is the square of the negative 4t to the 6? Okay, well, anyway, you just disregard the negative there, because as it says, we need to have always a positive sign in the trinomial set. So you square this. So the square of 4 is 16, and then the 6 times 2 will be 12. So 16t to the 12, yes, it's positive 16t to the 12. So the factors of 1/8 n to the 6 minus 60/40 to the 18 is equal to 1 half n squared minus 40 to the 6 times 1/4 n to the 4 plus 2n squared t6 plus 16t to the 12. Okay, guys, I hope you've learned something from my video today. I hope you keep on watching for my coming videos. And then do not forget to leave your comments. You can also suggest topic. And then uh, do not forget to subscribe and hit the notification bell for more video updates. This has been Teacher Justina, and see you to my coming videos. Goodbye, everyone, and that in all things God may be glorified.